Good morning. My name is Pavitra Paramasivam and my metric number is 33DCE20F2017. Today I am going to do Izod impact test, which is to find the impact resistance of mild steel and cast iron. Okay. Step 1 is select the Izod test specimen. So we are going to select cast iron. So this is the length 75.3, breadth 9.3 and 9.5 and lastly 5. So the next step is test for friction loss is conducted by adjusting the pointer to 164 joules. Then the pendulum is released by operating the lever without keeping the specimen. So we are going to release this pendulum, and loss of energy due to the friction is F equals to 2 joule. Step 3. The Izod test specimen as per Indian standard is IS 3766-1977 is placed in position. The position must be half from the hammer to get the correct data. The direction of impact must be opposite from the face of the hammer. The angle between underside of strike and face of test place is need to be opposite from the hammer. Step 4. The pendulum is released. The hammer striker against the specimen breaks it and swings further than the observation is noted down. This is for the trial 1. We are going to do 3 trials. So total loss of energy during the transit of hammer is 10 joule and energy for failure of specimen is 8 joule. So the next step is observation. We can see here the initial energy of the hammer, the average loss of the dual friction is 2 joule, and the total energy of the during transit of hammer 10 joule, and the energy failure 8 joule. And this is for cast iron for trial 2. The length, breadth and depth is right in here. We can see here. And we need to do the same thing again, same steps. So for here, the total loss of energy during the transit hammer is 5 and the energy failure is 3 joule. So we should take the reading, and these are the observation. These are for the trial 3. So we should do the same steps. So the total loss energy of this is 7 and the energy of failure is 5 joule. And these are the observation. Average energy for failure of specimen is 5.33 joule. These are the loss of energy and total loss of energy, energy for failure of a specimen. So we are going to do for the second, it is mild steel. So these are the length, breadth, depth of notch. So we are going to do the same steps. First of all, we need to test the friction. The friction is 2 joule. The next step is we need to put in the same position in the same direction, opposite direction, sorry. So we need to release, and these are the for the first trial. It is 46 joule and the energy failure is 44 joule. We need to use the formula that given. So these are the observation. 164 joule, 2 joule, 46 joule, and the energy failure is 44 joule. So these are for the second trial. Before the test, we should measure all the specimen that we are going to use. So we are going to release for the second trial, and the total loss of energy during this hammer transit of hammer is 56 joule, and the energy failure of the specimen is 54 joule. And these are the observation. 164 joule is the initial energy, 2 joule, 56 joule, and 54 joule. And for trial 3, and these are for trial 3. So we are going to do the same step. We are going to release, but the piece was not broken by striking energy of the testing machine, so the impact value obtained is indefinite. And yeah, so this is the observation. For average energy of for failure of specimen is 49 joule, And the third trial is the total loss and the energy failure is 0. In the end of the experiment, we can conclude that mild steel is more impact resistant than cast iron. This is because steel is excellent of withstanding sudden impact without bending, deforming, or breaking. This is due to the toughness of the material. Thank you.